Hello guys, my name is Engineer Ali. We want to talk about Galilean telescope, which are also known as opera glasses. Basically, they are referred to what? They are refracting telescope. They are refracting telescope now, and they use what? And it uses what? Two what lenses. Number one is that it uses what? Convex lens, or what we call the what? The converging lens. The converging what? Lens of what? Long what? Focal length as objective lens. And what happened to the second lens? Now the second lens we are going to use here is what we call a concave lens. This concave lens, or what we call the what? The diverging lens. Diverging lens are what? Of short what? Short focal length as what? Eyepiece lens. But note, objective length has a what? A longer focal length than eyepiece length, what we have talked about. And you can even remember through the word TOS. What does that mean? Telescope. Now, telescope is T. O is what? Objective lens, longer. Eyepiece lens is shorter. TOS, objective lens, longer. Eyepiece lens, shorter. Now, if we talked about that now, what is the kind of image formed by this particular man here? This one form objective lens form what? Real, inverted, and diminished. That is, the image will form the initial image from the sun, from the stars. Then the final image will now be what? The what? The final what? Image formed by a what? By a what? A convex lens. By a convex lens is virtual, erect, and magnify. And if they form virtual, erect, and magnify, what happened to the image? The image is what? The image is formed at infinity, is located, is formed at what? Infinity. So that means that what? Now don't forget, I told you that the convex lens form this image during inverted and diminished, while the concave lens form what? Virtual, which is final image. Virtual, erect, and what? Magnify, which you call the vein. That is the vein. Now, in this case now, let us do a kind of raw sketch about what? A Galilean telescope. This is the eyepiece lens. Then we have what? The what do you call it? The common, they are drawn in a common what? The common line passes through their what? Their center. Now there is a ray of light coming from what? Light. Now they're parallel, they will not meet at what? Now, at this point now, if they produce this image here, and this image produced by what? This the objective lens, which is O. Let me put it here. Maybe for the star is what? Real, inverted, and diminished. And it is formed at the what? The focal length of the what? The objective what? Lens. So from this point to this point where the image is formed by the objective lens is f naught. While from this point, from the lens, convex lens to the what? To the image formed by the objective lens is what we call the eyepiece lens. Eyepiece what? Focal length. Now there will be a dotted line here. This will be a dotted line. So that means the point of intersection of with the line passes through the what? The center of the concave lens will now what? Diverge. This one will diverge. This one will diverge. So if they all divert now, what happens is that what? They will now what? Go to what? Infinity like that. They will now produce the image at infinity. So that is how the image will now be formed. So the image will be formed at what? Infinity. Now the distance between the lenses are what? From here, from the objective lens to the eyepiece lens, it will now be equal to what? F naught minus Fe. So if I ask you the distance between the lenses is what? F naught minus Fe. So that means the length L equal to F naught minus Fe. Now that one is set to get. Now the magnifying power, or what we call the angular magnification, is equal to what? Objective what? Focal length divide by what? The eyepiece focal length. I think I gave something similar on that telescope, which is equal to F naught over what? Fe. M. Now, what you should know in this formula is that the higher or the longer the focal length of the objective lens, the shorter the focal length of the eyepiece lens, and the longer the higher the magnifying power. That is how it works. And don't forget that the final image is what? Then virtual, erect, and magnified. That is final image, and it is formed at infinity. This is what? Image produced by the what? Objective lens. This is the image produced by the objective lens. And do not forget that the image produced by the objective lens is real, inverted, and what? Diminished. It is real, inverted, and what? Diminished. So take note of that. Now the question is this. Now they can ask you, now why is it that this particular instrument is used for terrestrial telescope? Because it produces an upright image, an image that is upright, that is what do you call it? Virtual erect. It is erect image, not like the astronomical telescope. The image is inverted, is sending the image of the sun or the star on to the earth. So it's a disadvantage. So we cannot use such an instrument. It can only be used as what? A celestial telescope. Although this one have a disadvantage too, even though it's used as a terrestrial telescope, because it would to track and locate celestial objects or a moving object on the earth surface, on the terrestrial what on the earth surface. When an object is on motion on the earth surface, to track it is very difficult by this instrument, even though it's useful. Another thing again is that because of they have a low power or lower magnification, because of their narrow field of view. You understand that? So because of their narrow field of view, they have a low magnification. So that may compare to what? They have a lower magnification compared to astronomical telescope. So those are the disadvantages you can bring out from this particular instrument. But when you check their advantages, they produce a virtual array and magnified image, that is an upright image. Number two, they are suitable for what? Lower vision application. That means to produce a low vision application, something that has a low vision, you can use what? That means you want to produce a lens with what? Lower, a telescope with lower magnification. I think this particular one will be good for that. Vision with lower application. The next thing is that they are very good in terms of what? Production. They have what? Because economically you must look at it from the economical factor. They have what? Lower what? Manufacturing cost. They have what? They are very cheap to produce. These are the advantages in terms of economical factors about opera glasses, or which is Galilean telescope, which I want you to take home and digest it. Don't forget that he uses two glasses, two lenses. One is what? Convex or converging lenses. One is what? Diverging lenses. The image formed by the objective lens. Don't forget, the objective lens is what? It has a longer focal length, while the eyepiece level is a diverging lens or concave lens uses what? Short focal length. Don't forget the image, the final image produced is virtual array and magnified, while the final image or the image produced by the objective lens is what? Real, inverted, and what? And diminished. While the final image produced by the eyepiece lens is virtual array and magnified. So all these things you must know. Then make sure you know the distance between the two lenses. Don't forget that this diagram is at normal adjustment. So if I call it figure A, so the diagram in what? In figure A is the what? Is Galilean telescope at what? At normal what? Adjustment. Because at that point, the eyepiece lens and the what? The focal length of the objective lens all coincide, they meet at that point. Because if they did not meet, it means that it will produce an erect image here. This line will meet at the point and they will now produce an erect image somewhere here. So in this case now, I've been able to what? To explain basically what Galilean telescope or opera glasses are. Thank you very much. Please, if you know you enjoyed the class, just what? Press the thumb up button and also subscribe to our channel so that you can always get more and see us more. Thank you very much for watching. Returning viewers, thank you for watching. And the new subscriber, thank you. God bless you.